see the function up there. The first one is square root of x, and the other one is x squared. And it gives me some options on how I can create various things. So something we would have done with this last time, and this is actually the exact function that we did do this with last time on part B, we rotated this around the y-axis. And so I'm going to put in here, rotate around the x equals 0. You guys ready? Okay. So if I rotate around x equals 0, that is the y-axis. Did we do y-axis? Yeah, we did y-axis last time. And so if I push play here, you can kind of see this rotation happening, but it's kind of hard to see the way it's oriented. So let's pause this and let's get it to a better angle for us to actually see. So if I take this and I three-dimensionalize it a little bit, and I push play now, nothing shows up. Why would that be the case?
You don't have an axis selected.
Oh, that's really weird. Why would that go away? So let's go x equals 0. There we go. So now I'm going to push play again. And now we can see that rotation around the y-axis happening. You can see this bowl-shaped solid forming, but this is one of those solids that's not really a fully solid solid. It's got the big gap in the middle where you could actually pour water into it, and so you get this bowl-shaped thing. You can see it in all kinds of different orientations. What do you think? Does that make sense? Okay. So then the other question there at the top. Well, why is it? That's a restart. Why is it just continue to play? Sorry, what?
Why is volume negative?
I don't know what that whole negative number is all about.
Because I chose the wrong R.
Oh, yeah, there's actually, I think this makes sense because they want, notice how they label it outside function, inside function. I wish they would just say function 1, function 2. So I bet if we switch those, I bet you if we had x squared and square root x, I think that'll do it. Now we get the positive version of it. So inside, outside, that kind of thing. Okay, go ahead.
So that means that if we accidentally choose the wrong R for the big R and little r, all that will happen is it will just give us the negative.
You should get the negative of the actual volume.
We'll just flip it.
Be careful with that. We should talk about that today. We definitely will. Okay, so what if, though, what if we change this a little bit?
Oh, are we doing...
What if I decided to rotate this around something different? What if I rotated this around, say, not the y-axis or the x-axis, but what if it was the line x equals 2? So do you see that? You got that vertical line that just showed up there at x equals 2? If I decide to rotate it around that, I'm going to get a very, very different looking object. You can see here that it is going to be sort of bowl-like. You can see that rotation taking place. However, it's going to... Why does it just... This is really bugging me that it just keeps playing. It's not supposed to. There we go. Down here. It just starts. So let's go pause. There we go. So let's go x equals 2. And now I push play. And as I rotate this, as I kind of move this around, you can kind of see it forming. You can see that it won't be a truly solid. It's going to have a hole in the middle. And so this would be a nice example, like somebody just said, washers. You can kind of see like the department store washer concept taking shape here, right? You've got solid outer surface, and then you got an inner surface, but then you got this giant hole right through the middle. This is clearly washers, right? So this would be an example of where you've got an object which water would just pass right through if you tried to pour it in, right? It's got a big hole in it. Okay? So the whole point of this is just to help you visualize what's happening and make one decision. Should I use the washer method or should I use the disk method, right? And so in this case it would be washers, right? Because of that big hole in the middle. So you don't need to visualize like this perfect, precise shape and say it'll look exactly like this. Basically you need to visualize it to this point. Will it have a hole in the middle or some kind of concavity in the middle? Or will it just be a truly solid solid? If you can answer that question, you can answer what you need to answer and you can be okay. All right? So, let's talk about some details that go along with this. Where did you go? There we go. So, I want to try letters C and D here. So, let's get this sized about the right. Something like this. Come on, computer. Okay, so our region is the same region we've been working with. And so I'm just going to sketch that one out. And I thought here that I would work this first one with you, and I'll have you guys try D by yourselves. And I know, like when I first, like a week ago or whatever, when I first said, hey, we're going to do volume, and some people were like, groan.
That was me.
This was the thing. It was like, oh, but what happens when the axis is like over there? Mm-hmm. That was the big question. So let's focus in here and see what we can do. I really like the method that I use, not because I think I'm the greatest or it's the greatest, but I just think that it works. It works for my mind, and I feel like I can explain it well and show it well. And if you disagree, well, let's keep talking. Let's get to a better place. I'm not going to be sad if you say, oh, I didn't really understand that. It's okay, I get it. That happens sometimes. Okay, so I'm just going to get my region up here, and my region, let's see here, it's y equals x squared, and y equals root x. It's the same we just had on the computer screen. So here is y equals x squared.
Oh, they're really good.
That actually was, I was going to say something about that myself, but I didn't want to jinx myself for the next one. So here we go. Here's the y equals root x. Hey, man.
Wow.
I'll see you guys later. Have a good rest of your day. I'm out of here. No, I'm just kidding. Should just like leave while I'm ahead. Okay, so this is, purple is y equals root x, red is y equals x squared. We good with that?
Yeah.
I don't want to clutter up my picture too bad. Actually, this will be okay. I'll write it in here just so we can be clear. And then red is y equals x squared. Okay. All right. So do you guys know where that intersection point is? Obviously, you've got 0, 0, and then what's the other one? 1, 1. Okay, so that's potentially useful. So 1, 1 for that intersection point out there. And then we're told we're supposed to rotate this around the line x equals 3. So really, I should extend my line, my x-axis out here a little bit. Oops. That's not going to go well. Well, I should have quit while I was ahead. There we go. So my axis of rotation is going to be out there somewhere. And so I'm going to say that that is this green vertical line, something like that. And this is kind of my setup. So I would say your first thought here needs to be to address the issue of if I did push play on the little computer program and this, rotation started, would the resulting solid be truly, totally solid? Therefore, we use the disk method, or would it have some kind of gap or hole in it, hence the washer method? It's got to be washers, right? Can you see how all this space in between my region and the axis of rotation, all of that space would get rotated too, wouldn't it? That's the hole. That's the thing that creates, or the lack of thing that creates a hole. Okay, so I got to be honest, I've been doing this for a really long time, but if I'm doing one of these questions and I want to get it right, I'm not just messing around or something, as soon as I recognize that it's washers, I'm going to write this. V equals pi integral big R squared minus little r squared. That's my framework. And I feel like as long as I write that down, I could mess up some of the details possibly, but I'm not going to mess up the main structure of what I'm trying to do. I'm trying to set myself up for success. Okay, so the next thing I'm going to try to do here is figure out, should my integral, my integrand really be x's or should it be y's? And the thing that tells us that is the dx or the dy that's on the end. So what's the relationship between that rectangle and the axis of rotation? They've got to be perpendicular to each other. So would you guys be okay with this blue rectangle being my representative rectangle? It's perpendicular to the axis of rotation. That makes sense? Okay. So then this rectangle then is what type of rectangle? Dx or dy as far as the thickness goes? It's got to be dy. Okay. So what that means then is that every single element of my integral, including the limits, have to be y's. They have to be y's. Okay, so then I think to kind of jump into that, I'm going to go ahead and do my limits. So am I going to accumulate, as I accumulate these washers, am I going to accumulate in a bottom to top pattern or a left to right pattern? Let's draw in a couple more rectangles and see what that looks like. Wouldn't another one look like this? And another one look like that? So am I accumulating these from the left side to the right side or the bottom to the top?
Bottom to top.
It's bottom to top. I would start down there at the very bottom and I'd have this little short rectangle. They'd get longer in the middle and then again real short at the top. Does that make sense? Okay. So then as far as my limits of integration, the limits of integration are going to indicate my accumulation pattern. So for what y value would I start accumulating? 0. And for what y value would I stop?
1.
And this is a little bit unfortunate. Perhaps it'd be wise for me to change up my region a little bit because this point up here is 1, 1. It might be confusing. You think, well, okay, it's, whichever one you want, right? Because they're both 1s, but it's that one that I'm using. That makes sense? Using the y equals 1. Okay, so then I'm imagining that even if you struggle with these, most of you at this point maybe are like, yeah, this was the easy part. The hard part was the r's, right? Okay, so I want to try to spell it out for you, and I'm going to erase some of my rectangles here, and hopefully not too much of my nice graphs. So I do want to give you kind of a formulaic way of thinking about this, but I really, really want you to understand what's happening. So isn't the radius, the distance, like if you just think about radius in general, isn't the radius the distance from the center to the outer edge of whatever it is we're dealing with? Like if you think back to like 6th grade when you first learned about a circle and a radius and diameter and all that junk, the radius is the distance from the center of the circle out to the edge, correct? And so would you all agree with me that the bigger radius for this particular region, what color do I want to do? I'm going to go with red. No, I'm going to go with purple. Wouldn't you agree that the big radius is going to go from this purple dot out to this other purple dot? Oh, come on. Isn't that the radius from there to there? So I'm going to draw in a line to represent that radius. Okay. It's not quite parallel with the x-axis. I hope you can forgive me for that. That's my big radius, isn't it? So then, let's see here. The big radius clearly isn't always 3, is it? Is the big radius ever 3? Yeah, when we're down there at the very bottom at y equals 0, x equals 0, what are you going to call that? The radius is 3. What's the radius at the very top? Like up here. What's the radius there is 2, right? Okay, but then everywhere in between it's going to be some crazy decimal probably, right? Okay, so then how do we express this? Here's the way that I like to think about it. I'm going to draw in an orange line right here. what would you guys say that orange line, of course that orange line is going to vary in length, what would you say that orange line is? How would we express that?
3 minus the radius.
Let's see here. 3 minus the radius. Yes, that would be one way of putting it. Let's think of a different, simpler way of putting that. It's starting at the it's starting at the y-axis and moving right. What do we call that?
Well, isn't that H or X?
H. Where's H coming from? I'm lost.
Or it'd be the. Or never mind. I was tripping.
It would just be
Okay.
like 3 minus.
Yes, you were.
The 3 minus, yeah.
No, I feel like you're starting to talk to me about the purple line.
Yeah.
I'm asking about the orange line, and I think you skipped right over my point.
Yeah, I think I did.
So now Jack said it a second ago. Isn't X defined by that orange line? Like that orange line is from the y-axis out to the right. Isn't that what X is? Like an X distance is starting on the y-axis and going left or going right. That defines X. So I would say that this represents my X coordinate. So then if this is my X coordinate, how long is the purple line segment, which is the thing that I really want?
3 minus the x.
And I think that's what Santi was going for. So I could put in here, I could say that my big radius is 3 minus x. Whatever the x coordinate is, to subtract it from 3, and that's my radius. But you know you can't leave it like that, right? Because of the dy. So then for that outer surface, what is x equal to? Yep, you just take this and you solve it for x. So what I would do here is I would just erase the x, or maybe wouldn't have written it in the first place, and I would just write 3 minus y squared. So guys, this is the why it works part of the class. I really do want to show you, or like just kind of, you probably already seen it. I want to clue you in on like the how do you do this quick part of the class. We'll do that in a second. Okay, and then of course the smaller radius is from right here, this gray line. That's the smaller radius, the distance from the axis of rotation to the inner surface of this solid. So then, once again, couldn't we say that the orange line segment, isn't that, in its most literal sense, isn't that x? It's the x coordinate. And so the length of the gray line would be 3 minus the x. But yeah, I would want to replace that with what's equivalent to it in terms of y, and that would be square root of y. I want to be super careful here. Let's talk about this part. And let's not trivialize this. Let's do what Logan kind of thought through here. He said, all right, well then if y equals x squared for that inner radius, then he just said root y equals x. Technically, wouldn't it be plus or minus?
Yes.
So we're talking about first quadrants where all the x's are positive, so we would consider positive root y as our x coordinate. If we happen to be shifted over, like if we were in the second quadrant or something, or maybe the third quadrant, you're going to have to really think carefully about, should I be using the plus side or the minus side of this? It's going to be different, right? Or if it's, if the whole parabola or square root function could be shifted around, you want to carefully consider which part am I actually going for here, okay? Okay, so that's it. Let me give you the quick setup here. I'll just tell you, earlier I told you, hey, if I was doing one of these and I want to get it right here, here's what I would do. Can I show you exactly what I would do? I'm going to fill in a little bit more, and then we'll get an answer for this and talk about one other thing in a second. Once I understand this as washers, here's what I would do. Here would be my first right. I would go pi integral 3 minus something squared minus 3 minus something squared. That's where I would start. Because the way that if you have a displaced axis of rotation, and you're doing one of these washer methods, or for that matter, well, it didn't really apply to a disk method, but this will always work. And here's why it'll always work. With subtraction, like if I were to do something like 3 minus 8 versus 8 minus 3, I get two different numbers, don't I? One of them is -5, the other one's +5. But in the washer method, what am I going to be doing to all those numbers? Squaring them. So if it ends up being 3 minus 8 quantity squared, I'm just going to get 25, just the same way if I did 8 minus 3. So when you got a displaced axis of rotation, you really can just go axis of rotation minus the appropriate expression, whatever that happens to be. Okay? That's the quick way. You can always resort back to the whole drawing it out thing, and then that should work too. Can anybody use Math 9 real quick and come up with what this answer is? Please don't forget the pi. I would say the number one thing people forget here is to put pi. So can I encourage you, if you're doing a washer method, you can do it on your calculator. Please do this. Push these buttons in this order. Pi, math, 9. Don't push math 9 and say, oh, I'll just multiply by pi at the end. You'll forget. At one point or another, you will forget. So just go pi math 9, and then get all your details filled in. So can anybody do that real quick? The math 9, please do. I have one more point to make here. It's not just about the numerical answer.
So, correct me if I'm wrong, it does matter, like, so big R and small R.
Now that matters. Yes.
It does.
Yep. And that's what we're going to talk about here at the end, like how you could deal with that and what the implications of that.
Obviously, like, if I'm able to graph it, and get my point of intersection to get my bounds, and then look at the graph to be able to tell, which one's closer, which one's farther from
Yes.
the x. Is that all you're going to ask us to do, or is there another way to kind of figure that out?
I think you just have to visualize it. Yeah.
Yeah.
Visualize it one way or the other. Or maybe you'll get a graph. Maybe you have a calculator.
Yeah. These are kind of situations where we kind of would have a calculator most of the time, right?
Either that or the graph would be given to you.
Yeah. Okay. So the graph will be available.
Yeah, unless it's like ultra simple. Like if it was y equals 1/2 x and y equals x squared plus 4. It's a line and it's a parabola. I think we're typically going to err on the side of we don't want the graphing to be the issue.
Yeah.
But don't let that be an excuse for like I don't know how to graph a line anymore.
Right. It's like
Right.
if it's just like two kind of complex polynomials, like
I'm
assuming
that's
I'm gonna have a graph.
that's
with me
too much.
Somewhere.
That's too much.
Yeah. Okay.
Yeah.
That's fine.
Meg, you said 5.3 something?
5.341.
341. Do you guys agree with Meg's number?
I agree.
Okay.
Yes.
So I want to point something out to you. Jack, you can't answer because we already talked about this. What do you all think would happen if I was doing this question and I wrote this? What do you think would happen if I wrote that and then I used math 9? This would give me, it'd be negative 5.341. Okay? You see how I reversed the order within the integrand? I did little r squared minus big R squared. Okay, so this happens sometimes. So what I want to do is just give you some advice on how to deal with this, whether it be one of my quizzes or tests or the AP test or whatever. Here's what can I show you what you don't do? Let's hurt Stephen write this, because this is a total lie. Seen stuff like this, right? Where people are like, I messed up the order, and they just go equals, and because the volume can't be negative. And so they get one of these. Of course, this is totally false, and so you shouldn't be writing that. Neither should you be scratching out your old work or erasing your old work and starting from scratch. Here's what my advice to you would be. If you did the thing in red, just write something like, therefore, the volume is 5.341. Like if you're confident that the only mistake you made was flipping the big R and the little r, then just do something like that.
So would you get full credit for something like that?
Yes, you totally would. Because thank you, Sasha. See you later. With all those properties of integrals that we studied back in chapter 4, whenever that was, you can take your integrands and flip them around, and you can take your limits of integration, you can flip them around, and you can move the constant multiple in and out. There's all kinds of different forms they can take. And so it could be, I want to be flexible, because it could be, and this is kind of globalizing this, but it could be that someone learned, hey, just do one of the r squareds minus the other r squared, and if the answer is negative, just go with the positive version of that number. I've seen people that I've said this is AP test stuff, but I've seen people that have given, they basically have just gone with this route, and they've said, I have no idea if the order is right, but I'm just going to take the answer and do the absolute value of it. And if the result's positive, then it was already positive. And if the result was negative, then we're good, right? So I've seen people do stuff like that. I just don't want to I want to be flexible enough to where I am representing your actual knowledge to the best of my ability and skills versus, well, there was a technicality. It was right, and the work was actually valid, but I didn't like the order. I want to be flexible. It's got to be right.
So I'm not allowed to just put absolute values in there?
So this, yeah, so I think the other thing is, I would say this, Peyton, in all the experience I've ever had, people that get lazy and just say, well, I'll just substitute like actual knowledge with just like, I'll just absolute value everything or something along those lines, they invariably make other mistakes too because they just get lazy.
Absolutely.
So things that'll just like mess them up. So just be disciplined, and I just want to give you advice. Be disciplined and consider what you're doing, and you'll be fine. Just don't get lazy. Okay, why don't you guys try D? D, please. Similar question, same region, but different still. So check it out, D.
Let's get an actual answer.
What about the national anthem? Did you say something about the national anthem? Oh. I was just going to say, that is my kids' favorite part of any game they ever go to. My daughter will belt it out. Like she will sing over the singers. She's only 6, but she sings loud. It's fun. And the whole time my son is just yelling. He's just making noise because he didn't know what else to do. Pretty much. The other times, yeah, he just makes loud noises, and we say, Cliffy, why are you yelling? I don't know. All right.
Time math night.
Yeah.
No, solve it by hand, honestly.
But we should get extra credit for solving it by hand.
I think I would rather die than solve it by hand.
Gotta be careful with your calculator.
No.
You have a lovely tool that will do it for you.
What
if
she
you want
said.
to do it by hand. I mean,
It's high risk, high reward.
That's
If you don't assume it
logical.
happen, you can do it consistently and you get extra points.
Yeah, it's, it's not really high risk for high reward because even if you can use Math 9, right, you still have to write out your integral.
Yeah.
And honestly, the answer is worth 1 lousy point. The integral would probably be worth 3. So even if you don't have any clue how to use your calculator, or you took the chance for whatever reason and tried to do it, analytically, you still get 3 out of 4 as long as you know what you're doing. So it's not the end of the world.
Plus, there's no, not only is there no extra point, they won't do that in college, they'll kind of laugh at you in college if you ask a question like that. They'll also,
True.
There are no extra points in life, except for Jesus. Jesus doesn't require a workout integral.
I was going to say, he already did it all for you.
Yeah,
You just have to say, okay.
It's gonna hit math night.
With your mouth and with your heart, there are no integrals involved in that, so there shouldn't be any extra points involved here either.
Oh, but man, you haven't heard my infinity spiel yet. I gotta bring that sometime.
Okay.
Yeah.
Okay, Mr. Anderson.
I gotta find some time. Anyway,
I'll do that when we're reviewing.
I might. It's. I like it. It's a cool connection. It really is.
Is this our last? What unit we're doing after this?
It's 7, and it's or whatever. I don't even know what it's called as far as numbers go. Parametric and vectors. So it's a very physicsy. It's just 2 weeks. Basically, we'll do 3 days and a little quiz, 3 days and a little quiz. That'll be the semester once we get done with this.
Oh, so no more tests.
Wait, no more tests?
Dang, that means.
Well, let's see. Well, we've got our Unit 7, or Chapter 7 quest, which could go either way. And then after that, we've got a couple of quizzes.
Okay.
And then the final.
Okay.
Yeah.
Okay.
I have an answer.
Well, that quest could go there for you. All right, so guys, here we go. I redrew this picture here. What would be the biggest shift from one we just did to this one?
The axis of rotation.
Axis of rotation, the R's.
And the X.
It's X's, right? So all of these things are true. These are going to be significant changes here. This is -4 down here. And this is where things can get a little bit weird with how we do the radii. So let's see here. This is still 1, 1. What's the relationship between the axis of rotation and the representative rectangle? So there, I was going to say, so far the only person that's answered that question is Julia, but at least some other folks answered that. Say it one more time.
They're vertical.
The relationship between the representative rectangles and the axis of rotation, perpendicular. So yeah, vertical representative rectangles. Yeah.
Yeah, Meg. Well, I still got
Okay.
it, Nick.
Well, you don't know that because
It's a good life lesson. Like listen to the question that was asked, right? Like it would be,
Yeah, Meg. Yeah, Nick.
right? It would be like saying, "Hey, listen." It'd be like me saying, "Hey, how many points did the football team score on Friday night?" And your response is, "They won." I'm like, not what I asked.
Yeah.
I asked how many points they scored.
Enough to
Of
win,
course they
Mr.
won. Like,
Anderson.
really not.
I was going to say that's more or less a given. I just was curious how many points they scored, right? Okay. Okay. So, what is so important about drawing in the appropriate representative rectangle?
It tells
It's
us
dx's. Yes, it tells you the variable we're going to be using. So, I'm going to write in this. I would go volume equals pi integral, and I am going to write -4 minus something squared minus -4 minus something squared, and then of course, like you'd all just decided, dx. So I'm going to start right there. Limits of integration. Am I going to be accumulating from left to right or bottom to top?
Left to right.
It's left to right because of those vertical representative rectangles. So I'm going to accumulate from 0, x equals 0, to x equals 1. And now I just have to decide what is the appropriate expression to complete my radii. Well, the big radius goes from purple dot to purple dot. So then, how far is it? Like, would you guys agree with me that from here to there is 4?
Absolutely.
That's my, hey guys, could you stop? It's just like really distracting to me. I can't think when it's just this murmuring. So that's my -4 right there. So then the other part of this, of course, is this little part. I'm going to highlight this in orange. So from here to here, this is also part of that radius. What is that really? It's really y, right? From the x-axis up, that's a y. But as I get ready to write a y in there, I stop because I know that I can't write a y. It's got to be an x expression. What is y equal to for that purple graph up there?
Square root of x.
Square root of x. There you go. So I put in square root of x right there. And then, of course, the inner radius goes from here to there. And once again, this, as we already knew, was 4. But then that extra little bit, now highlighted in orange, that is a y. And so, but I can't just put a y in there. I've got to acknowledge that it has to be an x. So for that little part, y equals what?
X squared.
X squared, yeah. So then this goes here. And I've got it. I do want to say that somebody could easily write this, and I hope this would make sense to you. They write integral from 0 to 1, big radius squared minus little radius squared dx. And they might approach this a little bit differently. They might say, well, wait a minute, if this part, I'll highlight it here, if this purple part is 4, well then isn't the distance, isn't the radius 4 plus something? And they could say 4 plus y. Well, what's y equal to? 4 plus root x. And they could come over here and say, well, wait a minute, isn't this gray part? Well, that's 4, so it should be 4 plus something. Well, it would be 4 plus that little y, right? So it'd be 4 plus x squared. And they'd say, no. The thing you got up there in black, purple, and gray, that's not right. What I've got there in red is correct, but aren't they the same?
Yeah.
They're exactly the same because of the squaring. And so that's why I say you can approach it from this perspective of like piecing out the little pieces, and I'm totally okay with that. Or you can just do axis of rotation minus whatever the appropriate expression is. That will always work too. Santi.
For part C, could we do like 2 plus the y squared?
Say it one more time.
For part C, just like we did before, could we do 2 plus these? Just like we're doing 4 plus. Like
Let's see. Let's think about that. So 2
plus like root x and 2 plus x squared.
Yes.
Come on,
So
Steve.
you're saying 2 because that minimum distance is
From
2.
here to here is 2, and then it'd just be 2 plus this.
No, I don't think so. So
Try it in your calculator. And see if it is-
you certainly could. So, gosh, I don't want to clutter that out too bad. I'll just come up here. So, okay, so he's saying that the distance from here to here is 2, right, Santi? So, volume equals pi integral, minus dot 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 or whatever. So you're saying 2 plus, what would I add to the 2?
Root x. That'd be like y squared.
Y squared. And the problem with that is, so we get down to here, we have a 2. The 2 is still here. And the x is from here to here. Right?
Oh yeah.
And so, I don't know what that is. And I don't think that holds significance. Because sometimes people will find the volume of the air, in the hole essentially. That's not what this is either.
That's one.
So I would,
That right there is, so it's 1 minus y squared.
I mean, yeah. It is 1 minus.
Which, so for doing the whole thing, it's 2 plus 1 minus y squared.
oh, you're saying that the appropriate distance would be.
Yeah, which makes
Oh.
us.
That seems like we're overcomplicating it now.
Well, I'm just saying that 2 plus y squared would work, that if you tried to do it from the 2, then the distance that you're looking for, the distance that you're missing is 1 minus y squared. Or no, the little orange distance, remember the little orange distance is equal to 1 minus y squared. And if you add 1 minus y squared plus 2, you get 3 minus y squared.
Which it would have been a whole lot easier just to do it in one step instead of two.
Wait, why, I'm so confused, why doesn't that work? Can you explain
So
that again?
the big radius is supposed to be the distance from here to here.
Yeah,
How is this 2 plus this little distance equivalent to that?
oh.
I just don't think they're the same. So if you took this and you literally if it's 2 plus y squared, all you're saying is take this, you should be able to take this and just put it over here. It only gets to right there.
Oh.
And I don't know what the significance of that is, but it should get all the way over here.
How is this the same thing?
Because it's squared.
Wait, so.
So square on both.
Do you really?
So
yeah,
okay, so
I see.
here's what Jack was saying.
Because if you flip
He's
the
saying,
function, then
if you have this imaginary dotted line out here at 2,
Versus 16 plus 2 root x.
so this is an x coordinate of 1, right? And then this is x equals y squared. So he's saying that this little black chunk, he's saying that this little black chunk that extends just barely outside the region right there, that's 1 minus this. So if you take the 2 plus 1 minus that,
That makes sense.
you actually do get the distance, which 2 plus 1 minus y squared is just 3 minus y squared, which is what we came up with in the first place.
Yeah.
So I was just saying, we could make that work. You could logically piece all that together, but I just don't see a reason to do it unless you got confused and you're like, what do I do? And then you eventually do get it there. That's fine.
So those two are the same thing? Those
Yeah.
two?
Exactly the same. And you could confirm that with Math 9. And here's why.
Because I'm doing like the math in my head of like actually like squaring those things out
Uh-huh.
as like foiling,
Yeah.
and they're different.
I don't think so. So, yeah. Isn't this...
Oh, never mind. I'm tripping. We're good.
right?
Yeah.
And then negative 1 squared,
Yeah.
Is one.
Yeah.
and now we're to the same spot.
Okay. Gotcha.
Great questions. I love this. Okay, so give me some feedback. People that a week ago said,
I feel great.
I hope you feel better.
Oh, just that is the axis of rotation minus, and that was just what I needed to
Honestly,
hear.
Are we gonna do it?
I just needed to make one
Are we gonna do any where it's like we're gonna rotate it around like
Some diagonally.
It sounds so much.
We would just rotate. It'd be like a rotated conic scenario. We just have to rotate it back where we want it.
I've never rotated.
It's not worth it.
It's a lot of work.
I don't know. I think there's some proofs and such where maybe, but
Let's just rotate the axis.
just go back to here.
That's my favorite thing in physics is that you can just write the x and y axis.
Again, I would just encourage you all to have as open of a mind as you can. For those that have maybe seen this or done this before, and maybe you had whatever experience you had, just be open to what happens here. So this is sort of a difficult shift for some folks because what we've been doing is we've been finding volume based on rotation, like rotating some region around some axis. This is going to be finding volumes, solids, but not through rotation. It's through what we call accumulation of cross sections. So I just wanted to give you some visuals on this. So you can see on the left over there, I've got, looks like a couple of parabolas. Yeah. And then in that box with the gray plane right there, you can see those parabolas represented in perspective, right? So what we can do is we can build cross sections on this base. This base is not going to be rotating around anything. It's just going to be sitting there. And I like to think of it almost like plants growing up out of the ground, like a garden, except instead of flowers and tomatoes, it's squares and triangles and stuff like that. So check this out. If I made my cross sections equilateral triangles, whoa, it's a lot of them. So let's see here.
It's not that bad.
Can you guys see the triangles forming the cross sections now?
Yeah.
And then so here's the base still. You can still see the base, right? This is growing up right out of the base and forming this, I don't know, fairly interesting looking shape. I mean, you can see the base. We're looking straight down on it like an airplane right now. Now we're looking at it more in perspective. I kind of think this looks like sort of a mohawk or something. I don't know. Porcupine, there we go. Porcupine, good. And then, of course, you can have other things. Instead of equilateral triangles, you could have a square. Square is kind of a hard one. So again, same base. Base hasn't changed at all. But instead of equilateral triangles growing out of it, we've got this. Oh, it's just going to rotate for us. Look at that. We've got this square. Oh, wow. It's really slow. There it is. Yeah. Another good look. Here's one that's kind of interesting. Trapezoids.
That doesn't make a lot of sense.
So check it out. Go. There it is.
Nice.
Good time.
I thought the point of the trapezoid was that doesn't
Wait, so is
matter.
it like 45?
Is that like a very specific?
Looks like an equilateral trapezoid. It's basically an equilateral triangle with the top chopped off, right? So that's what this one happens to be. And can you see it? This one reminds me of like, doesn't that look like an alligator, like walking away from you? You can kind of see the tail,
Looks like a trapezoid.
top of his back. Oh, it looks like a trapezoid.
Looks like a stack.
It's going with alligator, but whatever. And again, the base is still the same. There's the base. And then, of course,
Sharpest spoon in the oven.
and we have that look too. So what we'll be doing essentially is this. Trying to visualize these shapes, these solids, and finding their volumes. As long as you can remember some really basic area formulas, and won't be so bad. Okay? All right. Have a good rest of your day. See you tomorrow. And like I said, if you are dying to see your quiz from yesterday, drop by after school or something. I'll be here during part of lunch too. So, all right.